Hi all, it's good to see you here again. Today's video is about the incident that is currently incapacitating the Hubble Space Telescope. I will try to explain what happened exactly, how NASA is solving the issue, what the risks are for Hubble's operational life. Hubble has been in orbit for more than 30 years, has seen 6 different crews around it, and has regularly brought us jaw-dropping pictures of the cosmos. Therefore, many people feel some kind of attachment to that telescope and are worried about its future. As always, timestamps and link to sources are in the description. Sunday, June the 13th at 8 p.m. GMT, Hubble's payload computer halted. The payload computer is a very old design chip used on many satellites over the past decades. It is located in the Science Instrument Command and Data Handling Module, which was replaced during the last astronaut servicing mission in 2009. The computer's purpose is to control and coordinate the science instruments and monitor them for health and safety purposes, while the main computer runs the other parts of the telescope, such as orientation or communication. This main computer regularly receives a message named a Keep Alive signal from the payload computer that tells him all is well. But when the payload computer halted, this signal was not received anymore, and the main computer then automatically placed all science instruments in a safe mode configuration and raised an alarm to the ground technicians. Of course, the first thing NASA tried to do on the next working day was switching it off and on again, on Monday, June the 14th. When it didn't work, they knew this was a real issue. So, after a few days of analysis, NASA's main hypothesis was a degraded memory module. In space, even protected inside Earth's magnetosphere, ionizing radiations are much more powerful than on the ground and can sometimes hit a critical part of an electronic device. Usually, it only generates a glitch in a calculation, but sometimes it can permanently damage electronics. An important telescope like Hubble is well prepared for events like this and has built-in redundancy for every critical component. There are 4 independent memory blocks aboard Hubble and only one is needed. NASA therefore proceeded to switch to another block on Wednesday, June the 16th. Unfortunately, that didn't work either. The command to initiate the spare memory module just wouldn't complete. Technicians then tried to initiate the first memory module without any better results, and just to be sure, tried again later on both modules, receiving the same exact error message, as one can expect. At that moment, you might be thinking that the initial hypothesis of a cosmic ray damaging a critical component in a memory block is starting to look less likely. One cosmic ray can only damage a few atoms in a component. If many cosmic rays hit, they will hit different parts of the craft and not generate the exact same error on a spare component. Anyway, just to be sure, on Tuesday, June the 22nd, NASA's technicians tried the same thing they did on the 18th, but with every one of the 4 memory modules, and received the exact same error message. At this point, they understood their initial hypothesis was wrong, and that another element was at fault, preventing any memory module to be accessed at all. As of today, there are 2 hypotheses. Either the standard interface hardware, which bridges communications between the computer's central processing module and other components, or the central processing module itself, is responsible for the issue. The team is currently designing tests to assess which is the cause of the problem and find a solution. It is more than likely that a problem on the standard interface or the central processing module cannot be fixed with a software update, but maybe NASA will come up with some daring plan and save the primary computer. But in the eventuality that this computer is beyond repair, there is another option. Just like the memory module, the payload computer has an identical backup, including the standard interface. The only thing to do is permanently shut the faulty computer down and start the backup, which has not been powered on since its installation in 2009. However, says NASA, it was thoroughly tested on the ground before installation on the spacecraft. Remember that old console you haven't touched for 12 years and that is collecting dust under the stairs at your parents' house? Try starting it up again. Would you be confident it could work properly? Yeah, probably not. That's why NASA is trying everything they can to salvage the primary computer. If the backup cannot start properly or does not solve the issue, then Hubble will be over. There is no way the USA or anyone for that matter could reach the telescope, grab it and replace the faulty parts. Even with the space shuttle and the robotic arm, this was extremely complicated. With only small capsules that lack a grabbing device, a manipulator arm, and the ability to perform an EVA that's just beyond our reach. Even if the backup computer doesn't solve the issue and Hubble is shut down, there's a new generation coming in. First, of course, is the James Webb Space Telescope that will open a new window over the infrared spectrum with its oversized reflector. Its launch is currently scheduled for autumn 2021, but will probably slip a little due to issues with the Ariane 5 launcher. But the James Webb Space Telescope will not be alone this time. The Nancy Grace Roman Space Telescope, or Roman Space Telescope for short, is in many ways the true successor to Hubble. Its primary mirror of 2.4 meters is the same size as Hubble's and will provide the same resolution or details, but thanks to up-to-date electronics, the field of view will be 100 times larger. The Grace Roman Telescope will launch in 2025, and with some luck, might operate alongside a still working Hubble telescope. We do not yet know how this issue on one of the most iconic science satellites will end, but one thing is certain, its path will be followed and the many vibrant pictures of the cosmos will never cease to amaze us. If you found this video useful, don't forget to like it, as this helps me reach more people. Also, don't forget to subscribe if you want more. Here, on your left, is a video the YouTube algorithm has chosen for you. And on your right is a link to my last video. I hope you liked this episode and that I will see you in the next one. This is Getting to Space, signing off.